welcome to our channel Knowledge Hub. Friends, subscribe to our channel and click the bell icon for the latest update. Today we're gonna start with your chemistry for class 12, and that is your class 22th. We had done your 21th class where we had completed your unit 1, unit 2, unit 3, unit 4, unit 5 and unit 6. This is a class unit 7, which is the P block element that we even though have to cover up, and that is also important in terms of competition wise. If I'm going ahead here as in the detail, so first we'll go ahead to discuss about which is the chemical properties that we have to discuss here. That is the chemical properties we have to discuss, and before starting with this, it's a huge request from my side to all the viewers to please go through the subscribe button and please like, share and subscribe our channel so that many and maximum people can get the information at once, and even you can also enjoy the video as well. On the same cases for the chemical properties, if I'm going ahead, we have to discuss about the oxidation state and the trends in chemical that is reactivity that we have to discuss here. On the same cases, we'll go ahead, which is oxidation states and trends in chemical reactivity that we have to discuss here. So in terms of oxidation state and trends in chemical reactivity that we have to discuss here, on the same case here, all the halogens that exhibit -1 oxidation state, and however chlorine, bromine and iodine that exhibits +1, +3, +5 and +7 oxidation state, and also explained below that we'll discuss here. For the halogens atoms in a ground state other than fluorine, for that the first excited state, and of course for the second excited state and the third excited state we'll discuss here. So we'll go ahead here, which is halogens atom in ground state other than fluorine. So that is for that we have here is NS, NP, ND. For the NS here, for NS, for NP, ND. So here for the same we have for NS that we have your rotations. For NP, and for the ND here as well, that is the one unpaired electron account for -1 or +1 oxidation state as well. We'll talk for the another one that we have to discuss here, which is on the same behalf of it, that is for the first excited state. And for the same we have here that we have for the second state. I will just go ahead. For the third excited state, so on the same cases here for the first excited state here, this is we have and for the spin as well. Here the third unpaired electron that account for +3 oxidation state. For the second excited state we have, that is we have spin, and on the same cases here as well Here 5 unpaired electrons that account for 5 plus 5 oxidation state as well for the third excited state here. That is 7 unpaired electron that account for the plus 7 oxidation state as well. In the same cases where the higher oxidation states of chlorine, bromine and iodine and are rarely mainly when the halogens are in the combination with the small and that high electronegativity fluorine and oxygen atom. Example in an interhalogens oxides and oxoacids, the oxidation state plus 4 and plus 6 occurs in the oxides of oxoacids of chlorine and bromine. The fluorine atom has no d orbitals in its valence shells and therefore cannot expand its octet. That being the most electronegative, it exhibits only -1 oxidation state. All the halogens are highly reactive. They react with metals and non-metals to form halides. The reactivity of the halogens that decreases down the group as well. On the same cases, the ready acceptance of an electron is the reason for the strong oxidizing nature of halogens. F2 is the strongest oxidizing halogens and it oxidizes other halide ions in solutions or even in the solid phase. In general, a halogen oxidizes halide ions of higher atomic number as well. On the same case for that, we have an equation here, that is, you can say that the reactions we have and that we have as follows, which is Fe2, F2 plus 2x minus will give 2F minus plus x2, where x equals to Cl, Br or iodine. Cl2 plus 2x minus will give 2Cl minus plus x2, x equals to Br or I, Br2 plus 2I minus 2Br minus plus I2. The decreasing oxidizing ability of the halogens in aqueous solution down the group is evident from their standard electrode potential that we have, that which are dependent on the parameters indicated here that we have to discuss. And for the same we have for the equations as well, and that we have to discuss here in the detail about it. And that is we have as follows. And on the same cases we go ahead, and that is we have to discuss about, and which is the reaction for the another we have is half x2 1 by 2 x of g, and that is delta h x minus gas delta h x minus aqueous. Here for the same cases that we have to discuss here, and even though which is on to the same category we have to discuss here, and that is to be where the reactivity, that oxidizing power of halogens that can be further illustrated by the reaction with water. Here fluorine oxidizes water to oxygen, whereas chlorine and bromine react with water to form corresponding that is your hydrohalic and that is hypohalous acids. And the reaction of iodine with water is non-spontaneous, and in fact that can be oxidized by oxygen in acidic medium. Just reverse the reaction observed is to be eliminated here. So on the same cases we have a reaction for that, and that even though we have to discuss about it, which is 2F2 gases plus 2H2O liquid will give 4H plus aqueous plus 4F minus aqueous plus O2 in the form of gas. X2 gas plus H2O liquid will give HX minus aqueous plus HOX aqueous, where X equal to your chlorine and bromine for 4I minus aqueous plus 4 H plus aqueous plus O2 gas, 2I2 solid plus 2H2O, that is liquid here. Now we'll discuss about another one that we have to go ahead here in the detail about it, which is the anomalous behavior of fluorine, that even though we have to discuss here. Anomalous behavior of fluorine, that we have to discuss here. In anomalous behavior of fluorine, like other elements of P block present in the second period of the periodic table, fluorine is anomalous in many properties. For example, the ionization enthalpy, electronegativity, and electrode potential, that are all higher that is or higher for the fluorine than expected from the trend set by the other halogens, and also that is your ionic and the covalent radii, which is your melting point and boiling point, enthalpy of bond dissociation, and electron gain enthalpy, that are quite lower than expected. And that is the anomalous behavior of fluorine is due to its smaller size and highest electronegativity, low fluorine-fluorine bond, and dissociation enthalpy, and non-availability of a d orbital in a valence shell as well. Most of the reactions of fluorine. So in the same cases here, for that most of the reactions of fluorine that are exothermic due to the small and strong bond that formed by it and with other elements as well. It forms only one oxo acids, while the other halogens for a number of oxo acids, and hydrogen fluoride is a liquid where the boiling point we have is 293 Kelvin due to the strong hydrogen bonding. Other hydrogen halides are gases as well. We'll talk about the first one, which will have we have to talk about it, which is your reactivity towards hydrogen. So reactivity towards hydrogen here, that they all react and with the hydrogen to give hydrogen halides, but affinity for the hydrogen decreases from the fluorine to iodine, and hydrogen halide dissolves in water to form hydrohalic acids as well. Some of the properties of the hydrogen halides that we'll discuss here, where the acidic strength of these acids varies in the order of that we have here, and that is in the order of we have HF, that is less than HCl, less than HBr, and less than of HI. So more that we have is for HI here. And on the same case, the stability of these halides that decreases down the group due to the decrease in bond, where HX bond, that the dissociation enthalpy in the order which we have for the dissociation enthalpy, if I'm talking about, that is for HF. Then we have your HCl, and that we have here the HBr as well, that we have, and of course that is greater than we have here is your HI. On the same cases here, for the same cases, now we'll talk about the properties of hydrogen halides that we have to discuss here, and that is also an important one. So let's go ahead to discuss about it, which is properties of hydrogen halides. So properties of hydrogen halides here, that we will discuss about properties. Property HF, HCl, HBr, HI. That we have property, we have melting point, then we have your boiling point, then we have your bond length, Hx per pm, delta H per kg mole lemurs, and then we have pKa. So for the same case we have to find out here. That is for the HF, for the melting point for HF is 190, for HCl it is 159, for HBr is 185, and for HI is 222. For boiling point talking about, this is 293, 189, 206, 238. This is 91.7, 127.4, 141.4, and 160.9. 574, 432, 363, 295. This is your 3.2, minus 7.0, minus 9.5, minus 10.0 as well. So the second we talk about it, which is the reactivity towards oxygen. Reactivity towards oxygen. In the same cases, their halogens form many oxides with oxygen, but most of them are unstable. Fluorine forms two halides, that is OF2 and O2F2. However, only OF2 is thermally stable at 298 Kelvin, and these oxides we have, and which is and the same cases for these oxides, if I'm talking about, that are essential oxygen fluorides, that because of the higher electronegativity of fluorine than oxygen, both the strong that is your fluorinating agent, which is O2F2, oxidizes the plutonium to PuF6, and that the reaction is used in removing the plutonium as PuF6 from the spent nuclear fuel, where chlorine, bromine and iodine form oxidizers, in which the oxidation state of these halogens ranges from +1 to +7, and a combinations of kinetic and thermodynamic factor that led to the generally decreasing order of stability of oxides formed by halogens, which is I is greater than Cl, then greater than of course bromine, and that the higher oxides of halogens that tend to be more stable than the lower ones as well, where chlorine oxide oxidize that Cl2O and ClO2, Cl2O3 and Cl2O7, that are highly reactive oxidizing agent and that tend to be explode, where ClO2 is used for the bleaching agent for paper, pulp and textiles in the water treatment as well, where the bromine oxide, which is Br2O, BrO2, BrO3, and the least stable halogens oxide, which is middle row anomaly and exist only at a lower temperature. They are very powerful oxidizing agent as well. Where the iodine oxides, which is I2O2, I2O3, I2O7, that are insoluble solids and decomposes on heating. I2O that is 5 is very good oxidizing agent and is used for the estimations of carbon monoxide as well. We'll talk about the third one, that is reactivity towards metals. Reactivity towards metals that we have to discuss here, where halogens react with metals to form the metals halide. For example, in the same cases that the bromine reacts with magnesium to give the magnesium bromide as well. And for the same, we have a reaction for this is your Mgs plus Br2I will give you MgBr2 solid as well. So where the ionic character of the halides that decreases in the order, which is Mf is greater than Mcl is greater than Mbr is greater than Mi, and where M is a monocovalent metal, and if the metal exhibits more than one oxidation state, the halide is higher oxidation state will be more covalent than the other one in the lower oxidation state. For example, SnCl4, PbCl4, SbCl5 and UF6 that are more covalent than SnCl2, PbCl2, SbCl3 and UF4 respectively. We'll talk about the fourth one, which is another one is your reactivity of halogens towards other halogens. So reactivity of halogens towards other halogens. So in the same case, for the halogens that combine amongst themselves to form a number of compounds known as interhalogens of the type which is XX, XX3, XX5 and XX7, where X is the larger size halogen and X is the smaller size halogen as well. Now we will be going ahead to discuss about the another question that is we have been given here, and that is the question is to be as follows, and the question is was like that fluorine exhibits only -1 oxidation state, whereas the other halogen exhibits +1, +3, +5, +7 oxidation state. Also you have to explain that. Let's go ahead for the same. Fluorine exhibits only -1 oxidation state, whereas other halogens that exhibits +1, +3, +5 and +7 oxidation state also that you have to explain. On the same cases where fluorine is the most electronegative element and cannot be exhibit any positive oxidation state, other halogens have d orbital and therefore that can expand their octets and shows +1, +3, +5 and +7 oxidation state also. On the same case, we have an inert questions here that we have to talk about it, where we have to considering the parameters such as bond dissociation enthalpy, electron gain enthalpy and hydration enthalpy. Compare the oxidation power of F2 and Cl2. The other question is give two examples to show the anomalous behavior of fluorine. C is the greatest source of some halogens you have to comment on. Now we'll go ahead to discuss about the another one that we have to even to go ahead. We are in the detail about it, and that is the question we have, the topic we have to discuss is about chlorine here. Let's go ahead with that. So we'll go ahead to discuss about chlorine. In terms of chlorine, that chlorine was discovered in 1974 by that is your Scheele by actions of HCl of MnO2, and in 1810 the Davy established its elementary nature and suggested the name that is your chlorine on account of its color. That is a Greek is your chlorus, which is equals to that like a greenish yellow. For the preparation of chlorine, if I'm going ahead, in terms of preparation, it can be prepared by any one of the following methods. So first we have by heating a manganese dioxide with a concentrated hydrochloric acid, and for the same we have our equation here for that as follows, which is MnO2 plus 4HCl give MnCl2 plus Cl2 plus 2H2O. However, a mixture of common salt and concentrated H2SO4 is used in place of HCl, where that is 4NaCl plus MnO2 plus 4H2SO4 will give MnCl2 plus 4NaHSO4 plus 2H2O plus Cl2 as well. By the actions of HCl on potassium permanganate, we have 2 KMnO4 plus 16 HCl will give 2 KCl plus 2 MnCl2 plus 8 H2O plus 5 Cl2 here. On the same case for the manufacturers of chlorine, where the Decons processes that they are the two process, so that we have to discuss here in the detail about it. So manufacture of chlorine. Manufacture of chlorine, we have to talk about it, and for the same, the first we talk about here is Decons process. In that, by oxidation of hydrogen chloride gas by atmospheric oxygen in the presence of CuCl2, which is catalyst at 723 Kelvin. So for the same, we have a reaction for that as well, which is for HCl plus O2, that will give 2Cl2 plus 2H2O here. So in the same cases, the second process we talk about it, and that we have here, which is your electrolytic process as well, that we have to discuss here. That is the second one. So on the electrolytic process, terms of electrolytic process, where chlorine is obtained by the electrolysis of brine, and that is the concentration of NaCl solution. Chlorine is liberated at node. It is also obtained by a byproduct in many chemical industry. We'll talk about properties here. In the same cases, for the properties that we have to discuss as well, that is important, and on the same cases for the properties, we have to go ahead in the detailed about it. In terms of properties here, it is a greenish yellow gas with a pungent and suffocating odor. It is about 2 to 5 times heavier than air, and it can be liquefied easily into greenish yellow green liquid, which boils at 239 Kelvin. It is soluble in water. Where chlorine reacts with the numbers of metals and non-metals to form chlorides, and that we have for that same case, we have your reaction for this here. 2Al plus 3Cl2, 2Al Cl2. The another equation is P4 plus 6Cl2, that will give 4PCl2. 2Na plus Cl2 will give 2NaCl. S8 plus 4Cl2 will give 4S2Cl2. 2Fe plus 3Cl2, that will give 2FeCl3 here. It has a great affinity for hydrogen. It reacts with a compound containing a hydrogen to form HCl. So for the same, we have here, which is H2Cl2 will give 2HCl. H2S plus Cl2 will give 2HCl plus S. Then C10H16 plus 8Cl2 will give 16HCl plus 10C. With the access of ammonia, the chlorine gives nitrogen and ammonia chloride, whereas with the access chlorine, nitrogen's trichloride, which is explosive, is formed here, and that is your 8NH3 plus 3Cl2 will give 6NH4Cl plus N2, and that is NH3 plus 3Cl2 will give NCl3 plus 3HCl. That is in excess here. This is being Cl to be in excess, and here in the NH3 is in excess here. On the same cases, with the cold and dilute alkalis, that chlorine produces a mixture of chlorine and hypochlorite, but with hot and concentrated alkalis, it gives the chloride and chlorates as well. And for the same, we have an equation here, which is 2NaOH plus Cl2 will give NaCl plus NaOCl plus H2O. This is NaOCl is your sodium hypochlorite, and that is cold and dilute in NaOH, and that is another 6,6A NaOH, that is plus 3Cl2 will give 5 NaCl plus NaClO3 plus 3H2O. This is NaClO3 is your sodium hypochlorite, as I told you, and this is hot and concentrated NaOH here. So with the dry alkylate lime, that is bleaching powder, so then we have your equation, that is 2CaOH twice plus 2Cl2 will give CaOCl2 plus CaCl2 plus 2H2O here, that we have to talk about it, and that is also an important one here. On the same cases, that the compositions of bleaching powder of CaOCl2 and CaCl2, which is Cs dot CaOH twice dot 2H2O, where that the chlorine reacts with the hydrocarbons and gives substitution products with the saturated hydrocarbons and addition products with unsaturated hydrocarbons. For example, for that we have here is your CH4 plus Cl2 at UV, CH3 Cl plus Cl. This is methane, and this is your methyl chloride. Another we have is C2H4 plus Cl2. Room temperature C2H4Cl2. Here this is 1,2-dichloroethane that we have. This is ethene that we have. So on the same cases, we have chlorine water on standing losses, that it's yellow color due to the formation of HCl here, and that is and HOCl, then hypochlorous acid, which is HOCl, that's so formed, that gives that is the nascent here oxygen, which is responsible for oxidizing and bleaching properties of chlorine as well. Here it oxidizes ferrous to ferric and sulfide to sulfate. So chlorine oxidizes sulfur dioxide to sulfur trioxide and iodine to iodate as well. In the presence of water, they form sulfuric acid and ionic acid respectively. On the same cases they had formed here, and that we have to even though go ahead here in the detail about it. So with the same we have our equation here, 2FeSO4 plus H2SO4 plus Cl2 will give Fe2SO4 twice plus 2HCl here. Now further we will go ahead, and that we even though have to talk about it, which is the another equation, that is Na2SO3 plus Cl2 plus H2O, which will give Na2SO4 plus 2HCl. Another is SO2 plus 2H2O plus Cl2 will give H2SO4 plus 2HCl. I2 plus 6H2O plus 5Cl2 will give 2HiO3 plus 10HCl here, that we have to talk about it. It is a powerful bleaching agent. Bleaching action is due to the oxidation here, which forms Cl2 plus H2O, that will give 2HCl plus O. So colored substance plus O will give colorless substance. I'll just write it down here. Colored substance plus oxygen, it will give colorless substance. Now we will be going ahead further, which we'll discuss here. We'll talk about it, that is about uses here. In terms of uses here, that is, it is used for bleaching a wood pulp that is required for the manufacture of paper and rayon, bleaching cotton and textiles, and the extractions of gold and platinum, and the manufactures of dyes, drugs, and organic compound such as CCl4, CHCl3, DDT, refrigerator, etc. In sterilizing drinking water, and the preparations of poisonous gases such as phosgene, COCl2, tear gas, CCl3NO2, mustard gas, ClCH2CH2, SCH2CH2Cl that we have. Now we'll go ahead with the question that we have to discuss here, which is another question, that is we have to solve it out, the 17th question here. The question is, write a balanced chemical equation for the reactions of Cl2 with a hot and concentrated NaOH. In this reaction, this proportionations reaction, you have to justify. Let's go ahead. Write the balanced chemical equation for the reaction of Cl2 with hot and concentrated NaOH. Is this reaction or this proportionate reaction justify? That we have to justify here. So for the same, we have an equation that we form here is 3Cl2 plus 6 NaOH, that will be 5 NaCl plus NaClO3 plus 3 H2O here. Yes, chlorine from 0 oxidation state is changed to -1 and +1 oxidation state as well. We'll go ahead further with the questions that we have to discuss here. We have the reasons for bleaching actions of Cl2, and the other is name two poisonous gases which can be prepared from chlorine gas as well. We'll discuss about the hydrogen chloride that we have to discuss here. That we'll discuss about it, which is hydrogen chloride. In terms of hydrogen chloride, it bleaches vegetables or organic matter in the presence of moisture. Bleaching effects that of chlorine is permanent. Glauber prepared this acid in 1648 by heating common salt with concentrated sulfuric acid. Davy in 1810 showed it is a compound of hydrogen and chlorine as well. On the same cases, we'll talk about for the preparations as well for this, and that is the preparation, we'll talk about it. For the preparation here, that is, in the laboratory, it is prepared by heating a sodium chloride with concentrated sulfuric acid, and that form here in as follows, that is NaCl plus H2SO4 at 420 Kelvin we get NaHSO4 HCl. That is your this is your that is the first step. Second step what they form is NaHSO4 plus NaCl. At 823 Kelvin it will give Na2SO4 plus HCl. So HCl gas can be dried by passing through the concentrated sulfuric acid, and this is your dehydrating agent as well. In terms of properties, we go ahead. So yes, for the properties that we have to discuss here. In terms of properties here, that is that it is a colorless and a pungent smelling gas that we have, and it is easily liquefied in a colorless liquid which is boiling point at 189 Kelvin and freezes to the white crystalline solid at freezing point of 159 Kelvin as well. It is extremely soluble in water and ionizes as follows, like when it forms is your HCl plus H2O liquid. It will give H3O plus aqueous plus Cl minus aqueous, which is Ka equals to 10 to the power 7 here. In an aqueous solution is called hydrochloric acid, and a high value of dissociation constant Ka that indicate that is a strong acid in water. It reacts with NH3 and that gives here the white fumes of NH4Cl. So it will give NH3 plus HCl, that will give NH4Cl. When 3 parts of the concentrated HCl and 1 part of the concentrated HNO3 are mixed, aqua regia, that is formed, and which is used for dissolving the noble metals, example like gold and platinum. And for that we have an equation for this that is to be as follows, which is Au plus 4H plus NO3 plus 4Cl minus will give AuCl4 minus plus NO plus 2H2O that we have here. Now another equation that they are forming is in terms of 3PT. We'll go ahead for that. For the platinum, we can say that. So for that we'll do it in a different here. So for the same we have to find out here the reaction we have for the PT, that is your 3PT, that is plus 16H plus 4NO3 minus plus 18Cl minus. It will give 3PT Cl2 minus 6 plus 4NO plus 8H2O here, that we have an equation here. And hydrochloric acid that decomposes salts of weaker acid, example like carbonates and hydrogen carbonates and sulfides, etc. For the same we have an equation for this. Na2CO3 plus 2HCl, it will give 2NaCl plus H2O plus CO2. Another we have is NaHCO3 plus HCl, it will give NaCl plus H2O plus CO2. Another we have Na2SO3 plus 2HCl, that will give 2NaCl plus H2O and plus SO3 here, SO2. Okay, so there we'll talk about uses for this that we have to discuss on the terms of uses. It is used in the manufactures of chlorine, NH4Cl and glucose, that from corn starch, and for extracting the glue from the bones and purifying the bone black, and that that is your medicine, that and as a laboratory reagent as well. We'll go ahead with another one, that is another question we have to talk about it, which is to be as follows. The question is, when HCl reacts with finely powdered iron, it forms ferrous chloride and not ferric chloride. Why? So when HCl reacts with finely powdered iron, it forms ferrous chloride and not ferric chloride. Why? So the solution for this we have, its reaction with an iron produces H2, and on that it will form Fe plus 2HCl, it will give FeCl2 plus H2, that the liberation of hydrogen prevents the formations of ferric chloride as well. Now we'll go ahead with the details and we'll discuss about oxo acids of halogens here, and that is also an important one. Oxo acids of halogen, in terms of it, due to the high electronegativity and as small sites, fluorine forms only one oxo acid, HOF, that known as fluorine, and acid in the hypofluorous acid, and that other halogens form several oxo acids. Most of them cannot be isolated in a pure state, and they are stable only in an aqueous solution or in the form of their salt. The oxo acids of halogens that I will discuss, and their structures that are to be discussed here in the detail about it. So we'll discuss about the oxo acids of halogens as well. That is also an important one here. On the same cases, we'll go ahead here for the oxo acids of halogens here. Here that is we need as hypohalous acid. HOF, that is your hypofluorous acid. This is the HOCl, which is hypofluorous acid. This is HOBr, which is hypobromous acid, and HOI, that is iodous acid as well. Now for the same we have here the second one we'll talk about, that is your halic third acid, which is your halous acid, we can say that. The another is halic or fifth acid, which is your halic acid. Another is halic seventh acid, that is known as perhalic acid, that we have to talk about it. So on the same cases here for the same. So on here, that is we have to talk about it. This is being the hypofluorine acid we have. On the same cases here for that HOCl, which is your, and that is your the fluorous acid, which is from HOClO, then HOClO2, which is your fluoric acid, HOClO3, which is perfluoric acid. The another we have for that is your, that is, this is HOBRO2, which is bromic acid. This is HOBRO3, which is pearl-bromic acid. The another we have here, this is HOIO2, this is ionic acid, which is HOIO3, which is periodic acid as well. That we have here to be as follows, and then now we'll discuss about more in the detail about it, and even though which we have to talk about it. On the same cases, so we have hypofluorous acid here, chlorous acid and fluoric acid and perhalic acid as well, that we have to find out the structures for this as well. So we'll go ahead. Here we have the structure is HCl. So this is your hypofluorous acid. Another we have HO Cl double bond O. This is your fluorous acid. Another we have oxygen H Cl double bond O double bond O. This is chloric acid. This is for the same oxygen hydrogen Cl, it is double bond O, double bond O and double bond O. This is perchloric acid. Now we'll discuss about the interhalogens compound that we have to discuss here, which is we have to talk about it, and that is also an important one here. And the same cases and that we have as follows. Interhalogen compounds. So in terms of interhalogens compound here, when two different halogens that react with each other and halogens compounds are formed, they can be assigned general composition on XX, X3, XX5, XX7, where X is a halogens of larger size and X of smaller size, and X is more electropositive than X. As the ratio between the radii of X and X increases, the number of atoms per molecule also increases. Thus, iodine 7 fluoride should have maximum numbers of atoms as the ratio of radii between I and F, that should be maximum, and then is why its formula is IF2 and having a maximum number of atoms as well. In the same cases, we talk about further preparations for that. In terms of preparation, that interhalogens compound that can be prepared by the direct combination or by the actions of halogens on lower interhalogens compound. The product form depends upon some specific condition. For example, for that we'll have is to be as follows: Cl2 plus F2 for 37 Kelvin, we get 2ClF. I2 plus 3Cl2, it will give 2ICl3. This is Cl2 is in excess and this is Cl2 and F2 is an equal amount. The another we talk about it, which is Cl2 plus 3F2 at 573 Kelvin give 2ClF3. This is F2 is in excess. We have Br 2 plus 3F2, that will give 2Br F3. This is diluted with water. Now for the another one is I2 plus Cl2, it will give 2ICl. This is in equimolar. For the same, that is Br 2 plus 5F2, it will give 2Br F2. That is F5, that is it is in excess here. Now we'll talk about the properties about it, and that we will have to discuss here, which is in the terms of properties, and that is also an important one here. We will discuss some properties of interhalogens compound as well, which is important here. So on the same cases for the properties here, in terms of properties here, which is some properties of interhalogens compound will discuss here in the following, and that is also plays an important role, because all these, when we are going ahead here in the details, so we'll have to discuss all of this as well, and on the same behalf of it we have to go ahead further as well. So on the same cases, these all are important, and as I told you, and these all are playing an important role as well. On the same behalf of it, we will have to discuss. So there are some properties that we have to discuss here, which is some properties of interhalogens compound. So here we have type, formula, physical state and color and structure that we have to discuss. So that we have to discuss here as well. The first we'll have xx-1. xx-1. This is for this formula we form as CLF, BRF, IFA, BR, CLB and ICL. So for the same, here we have, that is for the physical and the color state that we have. So for that it is colorless gas. This is pale brown gas. This is detected spectroscopically. This is gas. This is ruby red solid, which is its alpha form, and brown red solid, which is of beta form, and that we have. And this is the structures we have as follows. Now we'll talk about for the another element that we have is XX-3, which is for ClF3, BrF3, IF3 and ICl3C. For ClF3 it is colorless gas. This is yellow, green, liquid, yellow powder, orange, solid. That is the structure. For that we talk about it. This is your bent T-shaped, bent T-shaped, bent T-shaped and bent T-shape. Now we'll talk about it. That is the another one which we have to discuss during the following, but here we'll be ending it up because it will exceed it more an hour, and that we will be going ahead further, which we have to continue because it will not be ending it up in 5 to 10 minutes only. So we'll discuss that in the rest of the topic that we have to discuss in the next coming class here. On the same behalf of it, so in the next coming class we will be having discussed here, and now we'll go ahead as well, and that we'll discuss about in the detail in the next coming class, which is also an important one. So here will be ending it up, and first of all, it's a huge request from my side to all the viewers to please go through with the subscribe button and please like, share and subscribe to our channel, so that maximum many and maximum people can get the information at once, and even you can also enjoy the video as well. Other than that, if I'm talking about here in the detail, so yes, other than that of chemistry, we are dealing with a quantitative aptitude, which is where we have been two sections, that is arithmetical ability and the logic reasoning. Arithmetical ability and the data interpretation, where in arithmetical ability we have done your operations on numbers, LCM and SCM of numbers, and of decimal fractions, as well as the simplification, square roots and cube root, and then we have your averages as well, and we had started with the problems on numbers as well here. On the other hand, we talk about it. So yes, other than that, we had completed sociology and software engineering as well. In terms of reasoning here, that is for the reasoning we are dealing with, we had completed your verbal reasoning, where which is general mental ability and the logic reasoning, and the non-verbal reasoning, where we have to cover up the series, analogy, classification, analytical reasoning, mirror image, that mirror image, and that is your figure matrix as well, completion of incomplete pattern figure matrix as well. And even though we had started with another one as well, after that we talk about in terms of chemistry here, That is, the unit 1 is the solid state, general characteristics of solid state, amorphous and crystalline solid, classification of crystalline solid, crystal atoms in unit cell, number of atoms in unit cell, closed pack structure, packing efficiency, calculation involving unit cell dimension, imperfection in solids, electrical properties and magnetic properties as well. Unit 2 is your solution that we have to cover up, that is type of solution, expressing the concentration of solution, solubility, vapor pressures of liquid solution, ideal and non-ideal solution, colligative property and determination of molar masses, abnormal molar masses. Unit 3rd is your electrochemistry, which is your electrochemical cells, galvanic cells, Nernst equation, conductance of electrolytic solution, electrolytic cells and electrolysis, batteries, fuel cells, corrosions. Then you have your unit 4, which is your chemical kinetics. We have to cover up the rate of the chemical equation, reactions factor influencing the rate of the reaction, integrated rate equation, zero first order reaction, temperature dependence on the rate of the reaction, collision theory of the chemical reaction. Then unit 5 we have your surface chemistry. We had completed your adsorption, catalyst, colloids, classification of colloids, emulsions and colloidal roundels. Unit 6 is general principles and processes of isolations of element, which we have completed, the occurrence of metal, concurrence, concentrations of ores, extractions of fluid metals from the concentrated ore, thermodynamic principles of metallurgy, electrochemical principles of metallurgy, oxidation, reduction, refining, uses of aluminium, copper, zinc and iron. Where unit 7 we have a the P block element, where we have to cover up, that is group 15 element, dinitrogen, ammonia, oxides of nitrogen, nitric acid, phosphorus, allotropic forms, phosphine, phosphorus halides, also acids of phosphorus as well. Group 16 element, dioxygen, that's simple oxide, ozone, sulfur, allotropic forms, sulfur dioxide, oxo acids of sulfur, sulfuric acid. Group 17 element, chlorine, hydrogen chloride, oxo acids of halogens as well, and that we have to talk about it. Other than that, we'll talk about it. So interhalogen compound and group 18 element, that we have to cover up, and hopefully in the next coming class we'll discuss about it, because interhalogen compound we even though had started with, we'll completed that, and then after that we'll discuss about group 18 elements as well. In the same case for the unit 8 that we have to complete it, start with discussing about the D and F block element, where we have to cover up positions in the periodic table, electronic configuration of the D block element, general properties of the transition element of the D block element, some important compound of transition element, the lanthanides, actinides, some application of D and F block element as well. Unit 9 is your coordination compound, which we have to cover up the oneness theory of the coordination compound, definition of some important terms pertaining to the coordination compound, nomenclature of coordination compound, isomerism in the coordination compound, bonding in the coordination compound, bonding in methyl carboxylases, stability of the coordination compound, importance and application of coordination compound, that we have to end up with. And here we'll be ending it up. And first of all, it's a huge request from my side to all the viewers to please go through with the subscribe button, and please like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So thank you, hope you enjoyed this video. If you like this video, please give a thumbs up and give a suggestion in a comment box. Thank you.